Hey guys, I'm Jade. Today is my LeetCode review vlog on the 290th problem. Word pattern. We are given a pattern and a string S. We have to find if S follows the same pattern. Here follow means a full match, such that there is a bijection between a letter in pattern and a non-empty word in S. Let's see example 1 here. A matches dog, cat, dog. This is because A matches dog and B matches cat. And for example 2, A doesn't match dog, cat, fish. This is because A has already matched dog, so A cannot match fish again. Then, let's get started with our intuition to solve the problem. We can use two hash map to store the mapping rules from each character in pattern to a word in string S and vice versa. And inside this process, we also have to check their consistency. If we found inconsistency, we just return false. Next, let's get started with our code and detailed explanation. The first step, we have to take all of the words from the string S. So we have to create a string array. Let's say words equals s.split, and the split word is a space. Next, we have to check the length of words and the length of pattern. If they are not equal, we just return false, as they won't match each other. If words dot length is not equal to pattern dot length, we just return false. And the third step, we have to create two hash map to store the mapping rules from the characters in pattern to words as each other. Let's create the first hash map, and the key is a character and the value is a string, which is a word, and let's call it character to word, and it can be assigned to a new empty hash map. And for the second, let's say word to character, and we assign a new empty hash map to it too. Next, we'll traverse the pattern and the words simultaneously. First, we can create a for loop. Int I equals 0, and I should be less than pattern dot length. This is because the length of pattern and the length of words, they are the same, so we just choose one and increment I after each iteration. And inside it, we have to take the corresponding character and word out. Let's say character C equals pattern dot character add I, and the word is from words of I. Then we have to check if the character to word map has a mapping rule from C to word. First, we'll check if character to word map contains key of C. If not, then we'll check the consistency of the mapping rules of word to character map from word to C further. If not, we then have to check it further if word to character contains key of word. Oops. If so, we just return false. This is because this word is already mapped to a different character. So we found an inconsistency. And if not, which means we found a new unique character to word pair, and then we'll add it to the two maps. And the code is character to maps, character to word, put C to word, and word to character, put word to character, put word to C. And there is another situation, which means what if character to word exactly contains the key of C? And in this situation, we have to check if the consistency of the mapping rules of character to word from C to word, which is else if. Else if we have to check it further. If character to word, we have to get the character from the character to word map, and to check the equality of C of the word inside and the word we got in this iteration. Let's see, character to word get C dot equals of the word from the iteration. And if so, we just return false. This is because it has already exist a mapping rules and it doesn't match the current word. And this is our code inside this for loop. And out of the for loop, we just return true. This is because our string s successfully match the pattern. Then let's check for the correctness. And let's analyze word to character. In the lines 16, word to character, string cannot be converted. D, word to character, word to C. Let me check on this. Word to character, word to C. Word has now. String cannot convert D to character. Oops. The type isn't correct. So I have to revise it, which is string to character. Then let's check it again. And here comes to our time and space complexity analysis. Oops. So the time complexity, it is big O of n. And n stands for the length. The length of S, or the size of words. Oops, n is the number of characters in pattern. The number of characters in pattern. This is because we traversed each word and the character only once. And the operation in the hash map, like condensed key, are on average big O of 1. So the overall time complexity, it is big O of n. And the space complexity, it is big O of n plus k. And n is the number of unique characters in pattern, and k is the number of unique words in S. And this is the end of my LeetCode review blog on the word pattern problem. And I really recommend you guys to visit my online GitHub page. Here you can see detailed description notes, problem understanding, intuition, and Java code with very detailed explanation and the final complexity analysis. And you can also visit my GitHub repository here, which is the repository for the docsy file to build this online GitHub page, you can see the codes, the assets, the nodes here. And our node for word pattern problem is here. And thank you guys for watching. I'll see you next time.